software industry, okay, in software industry, how the people are developing machine learning applications, okay. So according to that, we will start it. Basically, we are a computer science background, right? So now we will go and we will work to develop some codes. We will just do some kind of database connections. We will do some software development, like all these things will be. Okay, fine. But this machine learning will be entirely different. So when we start to work with the machine learning, like so machine learning it will be always supporting to some domains. For example, healthcare industry, agriculture industry, and transport industry. Like it will be supporting some areas. So according to that, we can understand one thing. So we just doing some support for some other technology using machine learning. So so based on the data, like so the based on the data only this machine learning it's going to work. So basically, when we talk about what is artificial intelligence, it is mimic like a human, and it is taking the decision making, or it is acting like a human. It is a react like a human, and it is think like a human, and like we've had it, and even that it is thinking like a rationally, act like a rationally. Like this is what actually artificial intelligence. Actually, this is meaning of actually what it is meaning. So this artificial intelligence will playing with the biggest data. It is not playing with the simple data. Actually, it is playing with the biggest data. So that is the reason while you coming to talk about the machine learning, we have to careful about the data, because based on the data only we can decide this is what kind of problem. So what we can do, like we can think it. So like basically, suppose we just that's what I try to tell. We are the computer science students, but we are doing some research on agriculture based, or we are doing the research based on the like for example healthcare sectors. So basically we are not doctors, we don't know anything about that, what medicine, what kind of analysis we want to do, like anything we don't know. So basically what we know, so we know to build the some codes, so that's what we know. So now we want to work in agriculture, now we want to work in the other industries. So like how we can make it. Okay, so that is the thing. It is very important. So because as a computer science faculty, so we can decide all the things based on the data. Okay, so because why I'm telling this much important. So like entire machine learning concepts. So based on the data only, you will decide which algorithm we can use, which kind of method we can use. All the decision can we make it through the your data only. So that is the reason we have to focus more on the data. Okay, okay, fine. I'll just straight away I'll just go to implement, because you have to parallelly implement this all the things. Okay, so let's see that. Okay, so in machine learning, so we had it some like in machine learning there is two kind of problem statement. Okay, so there is a two kind of problem. So one is the regression problem. Second one is the classification problem. Okay, so we had it in the regression problems, classification problem, and we had it in the another one is the like there are so many problem statement. I'll add it. Okay, so, but we won't discuss all the things. We will look at the only two or three things. Okay, yeah. Yes, fine. Let's start that. So now we're coming to talk about that another problem statement. So in the another problem statement, so we can add it the clustering problem statement. Okay. So these are the three things we will focus in the FTP. So another one problem statement. So we can consider the reinforcement learning. Reinforcement learning. Okay, so there is a four type of problem, so this will consider the machine learning. Okay, so even that there is the deep learning as well as, but it is different. Okay, so deep learning is there also there, but it is a different problem statement. I'll tell you that how to that will be getting different when compared with the machine learning. Okay, so that is also, it is one of the problem statement. Okay, fine. So these are the problems, and based on the problems only we are start to work. So we won't discuss about the reinforcement learning here. So we will discuss regression, classification, clustering, and all these three we will discuss. Okay, fine. So here I'll just going to make you to understand what is the regression problem. So before we starting to start that all the problem statement, so we have to understand the data first. We know very well, but anyway, it's too to remember now. So that's why I'm just talking about that. Okay. So in data, so we can decide in two categories. I'm just talking. It's based on the problem only. Like I'm not coming to like talk about that what data, how it will be look like. Like I won't talk. So simply we are understanding what type of data can be used in the machine learning problems. So one is the numerical data. In the numerical, we know there will be like I hope that yesterday also I told you. So in the numerical, we had it in the data, count based data, and continuous data. Okay, and then next one categorical data. Okay, categorical data. So you know that this will be yes or no, like uh, are male or female. So like level one, level two. So some chemical based data will be having level one, level two, level three, like it will be that. Okay. So these are the things will be considered as the categorical data. Okay, fine. Okay, so according to that only we are going to work. So because these are the things will be help us to decide which algorithm we can use. Okay. So okay, fine. Okay. So I'll give you some problem statement. Okay. So 1 minute. 1 minute. I'll just give you a simple problem statement. So these are the existing one. Just for understanding, I'm just asking. Okay. So okay, fine. So I will give you simple problem statement. Okay. So basically, my problem statement is now you need to find out today temperature. So this is the problem statement. You want to predict the today temperature. Okay. Or you want to predict the weather condition of tomorrow. Like we have to find out. So how we can find out which algorithm we can use. So can you define it? So like we simply tell regression we can use. So how you can decide the problem statement? So in from the company or from the organization, so what they are telling, even that you can see some DST project also. So they will written in some statement of words. So they will expect to find out something. Okay. For example, same thing in that DST project. I hope I have seen 2017. So the project is we need to predict the weather conditions. Okay. So in Himachal Pradesh. Okay. So how we can do? So any idea? So this is a problem statement. So we want to use some algorithm. Which algorithm you people will prefer for that? Any idea? Like we want to talk something, otherwise it will be goes like a FM radio. So please, like I hope that this is a simple question. So you can tell whatever answer you are feeling it. So please. Yeah, I'm expecting some answer. So the problem is we need to find out the weather condition of tomorrow. So what algorithm, what technique we can use? What is kind what like sorry. So what is the problem? So what kind of problem? What kind of problem? It is comes under regression or classification or clustering. So we want to find out the tomorrow weather condition. So what kind of problem shape? So it will be coming under yes, provinces.
Regression problem, sir.
Okay, great, sir. Okay, great. Okay, I agree. Okay. Okay, fine. So, uh, any idea how you told, based on what you told, say?
Sir, here we can find the value of a independent variable based on the dependent variable. So we can predict whether what will be the forecast.
Okay,
If
okay.
we
Okay, yeah, please.
we can relate the two variables so that we can predict the value based on the other variable.
So like simply you told, sir, like simply means it is also like, you think and told, which means you simply saying that this comes under the regression problem. Okay. In regression, we are not specified what algorithm, what technique will come, right, sir?
Yeah.
Yes, great, sir. Good. Thank you, sir. Yeah, it is exactly right. So this problem is comes under the under the that same area regression concept. Okay. So like for example, so today all the people's like for example, I had a small experience with my colleague of research scholar when I do PhD. Uh, so that PhD scholar is married. He has children. Okay. So that like a scholar decide for her son. Okay. So he wants to do the computer science in AI based. Okay. So but he's trying to do that course, but for his mark, he's not able to get the degree. What she immediately thinks, so she planned to do the another degree, and after that, so she recommended the courses. So she's recommended me some IIT courses. So in IIT they are launching 1 year, 2 year courses, right? So that kind of courses like AI based and ML based courses they are doing. So immediately her decided to recommend the course for him. Like these are the courses that are available, so you can recommend. So like if you're studying this 4 years, you will get this one. So like you in that 4 year, whatever you are studying, you can get it in 1 year. Like she's recommended. So because what I'm asking, so today people like to learn lots of things. So for them, we need to do some recommendation for based on the skill, based on the knowledge. So we have to recommend the some subjects or some courses. So how we can recommend it? What algorithm we can use, or what kind of problem this? Any idea? So recommendations will comes under the which problem statement? Any idea? Yeah, please. Can anyone tell about that? Okay. So like we had a less audience. Okay. So let's have a small talk. So then we will start to implement all the things. Okay. So okay, fine. So I'm expecting some answer from your side. Okay. I hope I'm not receiving any answer. Anyway, so this recommendation will comes under the classification techniques. Okay. So we have to know that the base things. So like, what is the problem, which kind of problem, like, what is the problem statement? This statement will comes to which category? Like we have to know that clearly. So then only, so we can go with that, exact things. Okay. So then only we can decide the right algorithm. So like based on that only we can work on it. Okay. So I hope that let's start based on this. Okay. 1 minute, I'll just share some data sets and I will talk. Okay, fine. I'll share it my screen again. Okay. So let's start to implement that things. Okay. So first thing, let's see that regression algorithm. Okay. So basically in the regression algorithm, we have so many algorithms, but we cannot talk about all that algorithm. So we can talk only two algorithms. Okay. So for that only we have a time. So I'll discuss about the linear regression. I hope we already discussed actually. So we will discuss about simple linear regression, and then we will discuss about the multiple linear regression. Okay. So these are the two algorithms we are going to talk. So next thing, let's start to go with that another important thing. So we'll start to implement. So before we starting to that concepts, we have to understand how actually it really work. Okay. So we know these are the things will be used for the regression problem, which means that regression problem will help to predict some futures. Particularly, it will be work on the continuous data. So the regression problem always work in the numerical data. Regression problems always work in the works in the regression problems. Okay. So in that we know that, so like when it comes to talk about the regression problem, so that could be prediction based. Okay. Or like like just we will estimate some values. Okay. So like it is most of the examples like so like UT trending, weather forecasting, and Facebook, Twitter, like all social media, and even the newspapers, okay, e-newspaper, trendings. Okay, so that is the trending concept. Okay, so and all the things will comes under the regression problem statements. Okay, so actually when it comes to talk about regression, there is the 76 76 algorithms are there. So but we cannot talk all that algorithm. So we will study few things on. Okay, so that's all. So let's go with that. Okay. So next thing, so let's go to talk about the another thing. Okay. So in the next cell, we will discuss about the simple linear regression. First of all, I'll just go with the algorithm, and let's start about the how to implement all the things we will look at, and then we will go with the other things. Okay. So basically, when it comes to talk about the linear regression, I'll share some data sets with you. So please download the data sets because you can also implement that same thing. I'll share the data. You can take it any data. You can bring it your own data as well as. Okay. I'll share the data sets now. One minute, I'll share my data sets. Okay, so you can take some data sets. I personally sharing that e-commerce data sets. Okay, so you can take it that data set. Okay, fine. So here, what you need to do. So here you can start to implement the concepts. Okay, so first thing we have to understand that basically what is linear regression. So then we will work on this areas. Okay, so yes. And we know that what is the machine learning pipeline. So okay, so one is the input the data. Second one is the we need to analyze the data, which means you have to work with the EDA. Third one is the split the data. Okay, fourth one is the scaling the data. So scaling data maybe comes before the split the data or after the splitting the data. Maximum we will use the scaling the data after the split the data. So and it is even that there will come the standardization, standard the data. Okay, standard the data. Okay, I'll show you that. Okay, next one. So will comes under the after that split the data. We will do that thing. After that, we will create the model. We will create ML model, ML model. Okay, and after that, we will train the data with that particular model. So then fine, after that we will test the model. Next thing, evaluate the model. Okay, so that's all. So these are the 8 steps will be like compulsory. We need to do all that machine learning problems. Okay, fine. We will go with that. Okay. So here we have to know another one important thing. So we know that what are the problem statement is there and what are the algorithm will comes there. So we know particularly regression problem. So we will have the two algorithm we are going to implement. Okay. So how like no, so we like no, we just import that we know how to import the data. So even that we will going to now learn that the things how to create the model, how to train the model, how to evaluate the model. Like we will going to learn now. After that, what is the thing is there? We have to evaluate the model, right? For the evaluations, we will use some kind of formula. So particularly for the regression, so there is the mean squared error (MSE), and we have mean absolute error. So like there is a two important techniques. Okay, using that you can evaluate. Okay, fine. I evaluated by this technique, but how I can assure this like this model is good? How this model how I can sorry how I can decide so this model is good or not good? How I can decide based on the R squared values? Okay, which means accuracy value. Okay, that's all. So based on that only you can measure this model. Okay, let's accordingly we will start to work on it here. Okay, fine. So in similar way I will talk about the classification. Okay, now I'll just import my data. So you know well about that importing data. So I'm just going to import my data using pandas. Okay, so just do import pandas plus p. If you need numpy, you can add the numpy as NP. So I usually will use it. Okay, I'll execute this one. I executed. There is no issues. Okay. So whichever library is needed immediately, I'll use that library. I'm not using any other libraries. Okay. I'll create customer pd dot. So I'm still I don't know anything about the data. Okay. I even I don't know that what is the problem statement. Simply I have some data. So based on the data, I need to decide. As a computer science aspect, I don't know any subject knowledge. So about the domain. So I don't know anything about the e-commerce. I have some data. As a computer engineer, I received some data. So based on the data, so I need to do some program. So there is like there will be some questions, whatever requirements is there from the client side, they will make it. But in here, we generally take it, we just doing the experiments. Okay. So generally we like don't know any queries and all that things. Okay. We simply loading the data. So from the data, we are going to understand what is the input, what is the output. So in the input, what we are going to find out. So that is the things we are going to do now. Okay. So we did not read TSP. We just read the data. Like here, as usual, C drive, users, and then my name, my OneDrive. Oh, sorry, I'm in downloads. Okay. In the download, you can see that file, e-commerce data. Okay, fine. So I executed this one. I created so many cells because I don't want to go again and again, right? So I just created. Now I had it the data. So I want to see my data customer. Okay. So now I'll just use customer dot get. So you can see some data. In the data, you can understand there is a customer email ID, address, and we added some data. So like times, like we have something. And there is finally yearly spending amount. I hope the data, while you looking the data, so that time you can understand like this may be a output. Okay. So that other may be a input. Like we can consider, we can think it. Okay. Let's see that how we can implement all of this. Okay. So first thing I'll start to go with here. So I want to understand that things. So by that by visiting the data only, so we cannot decide because you know there is the data have around customer. So you had it. So you had it nearly 500 data and 8 columns. Okay, so by that I can't see 500 rows of data. So that is the reason I just want to do describe customer describe. So by that also you can decide how which are the data will be needed. Okay, so mostly I told you that so numerical regression will be work in the numerical data. So okay, you can take it accordingly that whichever data you need, you can decide it. So that is the yearly spend and the length of membership duration, and you have that time on website, and there is the app, and there is the average session length. Okay, so like these are the usage time. Like I hope that looking by the data, looking by the description summary of the data, you can understand. So these are the factors which will be more important, right? So according to that, I decided that one. Here we can just you can see that here we will do simple histogram how the data is distributed. That is very important. So because the data is normally distributed, that is not a problem. So if it is not normally distributed, we have to go with the other techniques. Okay, so we have to check the data is normally distributed or not. So using histogram, we can decide the data is normally distributed or not. Okay, so for that I just use a matplot library. So usually I'll use the matplot library inline function because it wants to run backend, and after that I'm just import matplot library pyplot as plt. Okay, and the customer dot hast and bins 30 comma size equal bin comma like a figure size, which means whatever we wants to give, you can like you can give it now. So and then color you can mention, like color usually whichever code you like to give, you can give. So like that html codes, right? So you can give also here also, for example a1 2 db, like I'm just giving some values. Okay, something. So I just executed this one. Okay, see that I had it in the some graph. So in that graph, so in particularly I directly launched histogram. I'm not mentioned which data I want to take it. Okay, I simply taken customer all data. Simply take all my customer data, whatever rows, whatever column of data I had it, simply I take it. But here you can see it is only came for numerical value, not for string values. Okay, so basically histogram will support only numerical values, not supporting the categorical values. Okay, so according to that, you can see the graph. So mostly while you're looking at the data, it is actually this is normally distributed, and this data also normally distributed. So like this data also normally distributed. We can make it some bell simple. That bell simple will be very apt for here, I hope. Okay, so there is no issues with the goes with the normalization. I hope that it is good only. So what we are deciding after that, well, let's look at the correlation. Next is thing we wants to find out the relationship between the data. Okay, so we just find out the looking the correlations. Okay, among particularly I focus for the yearly amount spending, how it is correlated with the other factors. Okay, so let's see that, because I decided when I just looking the data, so I decided so that may be good for output variable, right? So accordingly I'll just make it that correlation matrix, because matrix will be like correlation will be looks in the matrix format only. So there will be rows and columns, right? So customer dot correlations. Okay, so then if you want to like particularly focus with the I said in the yearly amount spent, so according to that we need to score. So what I do, correlation matrix, so I just wants to work with the yearly yearly right? So that is the yearly spending. I just taken this video, so I want to type and this time. Okay, I just make it that one. Okay, I simply taken that one. Okay, so after that what I'm telling, I'll just want to share this value. Okay, so here I just given ascending order, ascending. Okay, so I'll just run this. Yeah, sorry, actually the power cut, so that is the reason I'm just switch off my camera. So I'll start next. Okay, that I was done the mistake in the spelling. Okay, otherwise there is no problem. I will execute again. Okay, so there is the we found the like correlation with the see that you are taking only for the earlier ones. Okay, so you can see that how it is actually impacting. Okay, so like you can decide this will be good variable, we can take it this one. Okay, so the yearly spend amount will be correlated with the length of membership 80% and times on the applications, mobile application 49%, and in the average length of sessions which you used in the e-commerce sites, it is 35%, and time on the website it is very less. Okay, so you are not using almost. Okay, so this four it's very impacting. Okay, so that is the reason what I decided I can go with that using another scatter matrix. Okay, so let's do that. So if I want to do that another EDA analysis, which means that is also like kind of things which will be helps to do the scatter. So for example, I can directly input. So we have so many techniques to input the package. So pandas dot, so plotting. So I told you that using that pandas also we can plotting. So I do that now. So using pandas dot plotting, you can import something like scatter matrix. Okay, fine. So using that one I can work on that. Okay, I'll given the attributes. Okay, I'm just giving okay attributes, and then you are giving some variables. So which are the variable I selected here? So yearly amount spending and length of membership, a time on app, average length, and time on the web application, which means website. So these all the factors I'm just taking now. Okay, I'm just taking all the factors. Okay, so then what I do, I try to make it the um, scatter diagram. Okay, I just simply make it scatter matrix, and after that I'm just mention customer. Okay, so inside customer you are mentioning attributes. Okay, so after that you are mentioning that whatever size and all the things you need to go, you can give. So like size, I just given the value 15 comma 10, like that. And after that I just wants to give color. So that color code also you can give anything. I just given some colors. Okay, I don't know what color will be going to come. So after that you need to mention. So you will like making the scatter plot with that using histogram also. Like we will use the histogram also, like in the in a center points, like we do the scatter matrix for all the variable. So in the same thing, so you want to create the histograms with the middle of the places. Okay, so what is the thing I do, what I do here, I simply here I just make it HIST. Yes, this one. Okay, so this will be making the new histograms. Okay, so in this place you can mention that what color you want to do that. Okay, so you can make it any color there, but I simply given for example color. Okay, so it just looks like a dictionary. According to that only it will be run. Okay, so after that given, so you need to mention that another value in the list. So in the list you can mention some colors. Very list, yeah, right? Yeah, okay, fine. So like I just given some values. According to that I'm just executing this one. See that? Yeah, okay, I'm facing some color code issues. Okay, yes, yeah, color code was the issues. Okay, I'll just given some meaningful thing. Okay, yes, you can see it. Okay, so I given some values, so you can just customize. You can visit the HTML and you can select which color you like and you can give a code. Okay, so you can see it here. There is the some data. So in the data you can see that this is the middle point which I have created by the using the histo the underscore KWDS. Okay, so these are the properties. It is need some time to learn all the things. Okay, basically what I do, so we using the pandas, we just scatter the data so you can understand how this data has been scattered. That's all. Okay, let's go to the another process. In the another process, we are not yet coming to create the very important thing, okay? Because we want to create the machine learning model. Still, we are not started. And after that, I have another things because we don't want to spend much time on these cat, like no, in this particular diagrams, okay? So we can easily make it things. So even that, if you want to build that another thing, plot, which means that plot means we will create the some scatter plot with the some level based. So that is the reason I just made it all the things already. So you can see in this code. So this is also making that same kind of. Yes, actually it is represented the dot, red dots will be represent the higher amount, and so you can see that spend, and like blue ones will be for the two lower amounts, and you can see that with the dots of that length of membership also we can see it, okay? So then we will go with the another thing in the another one. So let's start to regression algorithm. So here only we are coming to talk about the regression algorithm. So regression algorithm formula everyone knows, so that is the reason I'm not going much about that, okay? So we start linear regression, okay? So basically this is will comes under the supervised learning technique, okay, containing that it is going to predicting the continuous variable, that is very important. So it is will be going to predict the continuous variable, okay, continuous variable values or values, continuous values or whatever it is, okay? So it is predicting continuous values, that will be right, okay? And after that, very important, it is done by like whatever we are done that training model, using the training model, so we can find it, okay? So when we coming to talk about that linear regression concepts, not only linear regression, in all that machine learning concepts, we had the data in the x and y, okay? And I will use X always capital letter, Y always small letter. X is always input and Y always output. So this is what we people will say. This is a independent variable. Okay. So this we will consider as the dependent variable. Okay, fine. So according to that we will work. So even that there is the name is called target variable. Target. So these are the names will have for X and Y. Okay, according to that we are going to develop that one. So basically when comes to talk about that linear regression formula, okay, so LR formula, linear regression formula, okay. So this is the formula. So in the formula you can see that it is for helping to prediction. So so that x1 will be considered our input variable. So whichever data we are giving to as an input, so that will be considered the independent variable. And at the same time, so for making the slope, like if there is the regression will be looks in the some kind of diagram, right? So it will be looks 1 minute. I don't want to confuse you. I'll make it to simple diagram, simple one. Okay. So we know that diagram will be looks like this, right? So like in the linear regression, the line will becomes like that, data will be like looks like that, right? So here fine. So if you want to create the slope, so if you want to create the slope, so you can go with this theta one. Okay. So if you want to introspect, which means it will be help us to adding some bias with constant values, that will be comes in the theta slope. So that is actually called introspect value. Okay. And this why it is always called as the dependent variable. Okay. Fine. Accordingly, we can proceed it. Okay. Fine. So next thing, so we have to focus to implement that regression algorithm. So first thing in machine learning, we know machine learning learning from is learning from past data. Okay. So how it is actually learned from the past data? For that, we are making simple one. So how we are making or how we are asking to learn that past data? It is very simple. So first of all, we need to split the data. Okay, we need to split the data, or we need to just tell first of all, we have to select the features. We have to select features. So what that features we need to select, we need to tell which is the input, which is the output. So that is the reason I just mentioned which are the input I want to put. So I just taken the data customer, okay, customers. In the customers, I want to specify my inputs. So I take average length, and I'm taking time of mobile application, web application, and then membership. So like I just taken these data. Okay. So these are the numerical data. I'm just taking only numerical data only, and at the same time, it is a continuous data as well as okay. I just considered all my inputs now. Okay. I taken from the X and just made it that one. So there is so many techniques to do. I simply for making understand. So I'll take it all the columns directly. Okay. After that, I want to mention what is Y. So that is also from the customer only. Okay. I mentioned what is my output. So that is, yearly amount spent. Okay, fine. Okay. So then I executed this one. So I decided what is my input. Okay. I decided what is my input, and I decided what is my output as well as. So now, and we know that the machine learning process, machine learning, it is not a traditional programming. So in a traditional, so we will have an input, and then input will be do the some process. Okay. So that after process, we will get the output. Okay. So this is the traditional program. In ML program, okay. So we will do input plus output. Then we will go to work with the process, and then we will get the output. Okay. So this is the techniques will happen. Okay. So but in this particular program, like in a machine learning program, so we do same thing, like we just divide the data. So we just separated, or we selected that which is input, which is the output. According to that, we are just going to send that model. So machine learning process, that model, it is going to learn input and output. So for that, what we need to do, we need to split the data. We need to split the data. So input as wants to split, and the output also wants to split. So that is the reason I just use from sklearn dot model selection. From first, it's not going model selection. So you don't have to type it all the statement. So while you starting the some keyword, you can make it tap and enter tap. So it will be all the codes will come. So okay, sometimes system maybe get slow. So that is the reason not came. But most of the time, so it will comes like this. You can make it tap. That's all. Okay. So then, so you just executed that first one. I hope that I want to split my data. Usually, whenever we split the data, we have to give 4 variables. Okay. So that 4 variable is X training, Y training, X test, Y test. So, but you need to give the order wise. That is very important. First X train, second X test, Y try, Y test. So you can see this X and X training and test. That X will be always capital letter, and Y here it will be in the always small letter. So according to that, you are doing multi assigning. So I just using the split function inside the split function. So first step, and the first step, what we need to do. So first step, we have to tell what is input, and you need to do second step, what is input, what is output. So you are telling that one. So what is next we have to tell? So what is the splitting size of data? So I need to split the data size. Okay, so I given training test you can give, but I'm just giving only test size. You can give any one of the things. So I will prefer the test size. So I need to go with the 0.20% of test data. Okay, which means 20% data for test, and remaining 80% of data set will be going for the training. So in that aspect, I need to execute. I'll just execute simply. Yeah, there is no issues. I done it. Okay. So what next we need to do? So we have to start the create the ML algorithm or ML model for the model. Okay, so I'll just going to create the AI ML model. So here you need to understand that if you want to work any model, each and every model will be comes in the different packages. Particularly if you are working with the machine learning based algorithms, everything will come from the sklearn model. Sklearn, this is the package. Okay, so this is the package which will support all machine learning libraries. Even that if you want to know very depth about the concepts, you can visit the site and you can see the regression problems. And the regression problem, you can look at that all the kind of things, what they are coming, like what are the algorithms will comes, like how they are using the linear regression, sorry, how they using the regression concepts here. Like you can get all complete idea here. Okay, so okay, fine. So let's come to here. Let's start to create. So if you want to create that one, so you have to go with that some important packages from sklearn, and then metrics. So metrics always helps to measure. Sorry, we don't want to go with the metrics. Later we will go. So sklearn import. Then I want to import the package. That package is called linear regression model. I simply go with linear model. So in that, after I'll just mentioning from, and I just want to do the sklearn. Okay, and after that I'll give a metrics. Okay, so this metrics will help to evaluate the linear model. So then I'll import it. If I want to evaluate the model, I told you we can use MSE, which mean squared error. Okay, mean squared error. I'm using mean squared error, and I use that R squared values because I want to know that my like my model accuracy. So that's why I just need to get the R squared score, and after that even that I'm adding mean absolute error as well as. Okay, so these are the files are very important. So I added one more important package because these are the mathematical calculations, so we have to avoid some mathematical relevant issues. So that's why I'm just adding math function import sqrt square root. Okay, so okay, fine, I'm just executing that some important packages. In the package there is no issues. Okay, so here I'm just going to create the model or train the model. Okay, so first thing I just create the model first or initiate using simple keyword. I just going to create linear regression model. Okay, LR. Okay, model. So simple. I'll just create the model. Okay, so we have to use the linear model. So in the linear model, you have to mention what kind of algorithm you are using. So I'm using regression, okay, linear regression. I use the linear regression, that's all. So after that, you need to mention, okay, after I just create the model. So, okay, model was created in AI, okay, so the model wants to learn it now. So if model wants to learn it, what you can do, so you can just go with that model, LR underscore model dot dot one minute, it's not linear regression, okay. Okay, sorry. So we will go with the LR dot model and fit function. Okay, inside the fit function, we are giving your inputs. Like what is your inputs? This is your inputs, right? So what you are giving here, you are giving inputs X and Y. In the some cases, you can give this X train and Y train. Okay, so you can give X train and you can give Y train. Okay, so what I do simply here, I'm not giving that one. So because I tell you that we had a clear data in the case. So that is the reason what I do simply, I'll give an X comma Y. Just assume. So just assume. The model it is going to directly learn from that our original data. So what I was not doing, I was not feed this data. Don't worry. In next example, I will feed this. So in this example, I'll just given the data directly X and Y. Yeah, so model it has learned that X data, Y data. So it has learned what is input, what is output. So according to that, so it is model, it is like, it is learned. So now I want to predict that what actually it is learned. So by that X training test data, by X training test data, so we are predicting how model it is going to work, how it is actually working. I have that variable Y prediction, whatever variable you can give, you can give. So model dot LR underscore model dot predict and X test. Okay, X test. So now I'm just executing this. So now we added some prediction of X test data. So these are the prediction of values for the X test data. Okay, so these are the prediction of X test data. Okay, fine. So you know what will be in the X test data? So in the X test data, you can see some rows of values. Let's see that. So these are the values you have. For example, if you go with this data, you will predict at the 56.3. Okay, and suppose you are going with this data, so it is predicting somewhere. Okay, so like this. Okay, so that is the predictions, okay, happening for the X test data. So these are the inputs to the model. The model it is predicting for all the rows some values. Okay, fine, it is predicted for the test data, whichever test data we are given. So we had a predictions, but we cannot ensure this prediction every time, right? We have to do one thing. So we have to ensure these things are right or wrong. For this, we have another technique that is called evaluation. I hope we will go with that. Okay. So here we have to check that how this model was predicted, how it is actually like no performed. Model it is how actually performed. We need to check model performance, which means we have to check is it good model or not. Okay. So first thing we can go with the coefficient. Okay. So we can go with the coefficients. Um, okay, fine. Dot coefficient. Okay, so this is what the value of coefficients. Okay, so this is the value of coefficients. So you can see that coefficients value. So I will explain laterly. So I may have some factor as well as I'll make it in the another one, and then I will explain. Okay, so after that, if you want to check the model performance, you can go with the LR underscore model dot introspect. I told you that using that introspect as well as you can measure it. Okay, and after that you have that r squared value, so that is also you can use it, but here I just use r squared squared squared. Okay, and then you can make it that so here if you want to find out r squared values, it is different. So you have to go with your test data, y test data, output test data, and same thing. So that is the prediction, right? So we need to comparing this prediction with the already existing data. So we had it in the y test data, right? So we are just comparing how it is worked. Okay, so for that I just doing the r squared function. There is a mathematical calculation. So it is just going to find out that values using that y hat, which means whatever we find out. Okay, so this is the prediction of y hat value. Okay, so according to that, let's see that score. So the model it has nearly predicted 98% accurately. Okay, so fine. So next thing, so we will start to knowing another thing. So we want to tell, like we want to tell how this model it has done a mistake, which means we want to find out the model errors. Okay, so for that I'm using mean squared error, mean absolute error, right? I'm just using now mean squared error. So mean squared error. So in the mean squared error, you can mention the same way what is the y test and what is the x test. Okay, I given this data like you can see. So it is actually 7.46. Like it will be have a error. So finally, what we find out from this, okay? So it is representing that average of session length, time size, like all that input based. It will be predicting that coefficients and accuracy, all the things it is actually predicting. So the best possible of this model can be accurate score can be achieved until 1, but we had it in the 98 percentage, which means that our model it is performing 98 percentage accuracy. Okay, so that's all. So here we have seen something RMSE, that is called root mean squared error, or we can call it as a mean squared error. So this is the distance between the vectors. Okay, so it is actually it is a distance between the vectors of predictions. So it will be having as a target values. Okay, so that's all. So we had a target value, right? So therefore that the target value vectors distance we will measure as the error, that will be 7.4. Okay, I hope we done a good model. So I hope I will share this one, you can also follow it. Okay, so in the first example I want to make sure to go for like go for that some clear thing. So that is the reason I'm not given it. Okay, so in the next case you need to do the same activities. Okay, so are you ready to do the next program? Do you have any doubts about this linear regression? You have any doubts in the first linear regression concepts? Do you have any doubts? Okay, there is no queries. Okay, fine. Oh, so let's go with the another thing, classification problem statement. Okay, so this is the we will simply goes with the regression problems. Okay, so next we will implement the like we will go work with the classification problems. Okay, so let's start with the classification problem and we will implement the 7 algorithms. Okay. 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 So now we are going to talk about the classification problem. So this is also going to decide by the data only. So whatever data we have, according to the data only, we will decide. So what algorithm we can decide, or like what algorithm we can use, and how we can decide this algorithm. Sorry, this problem will comes. Okay. So mostly when it comes to facing the categorical data, we will go with the classification. But this is the base only. You can apply for the classification. You can use the regression concepts as well as. So for the same regression, you can also go with the classification techniques as well as. Okay. So thing is like we have to know as a fundamentally like this is entirely based on the data only. So according to that, we can get the clear idea. So for that only, I'm just making this. Okay. So classification will comes under the based on the categorical data. Okay, fine. Next thing what we need to know. So what are the algorithm will comes under the categorical. So first thing, so it will comes logistic regression. So it is a kind of regression family of algorithm, but it is only for doing the classifications. Okay. Second thing, it will comes naive bias. And third thing, ANN algorithm. And fourth one is the decision tree. Fifth one is the random forest. And the sixth one is the SVM. Okay. So these are the 6 algorithms or will comes in the categorical data and particularly for the classification problem. So particularly for the classification problem. So the same algorithm can be used in the regression as well as you can mention that logistic regression also will comes for the regression concepts, and even you can use the support vector machine also will comes for the regression. Like you can use it, but thing is like we just commonly understood there is a 2 category of concept and that will be supporting for this kind of data. That's all. Okay. So according to that, let's start to implement that algorithm one by one. Okay. So if you're ready, please like inform me. I will just go with that accordingly. Okay. So first thing, I'll start that algorithm, logistic regression. Okay. Then I'll go with that. Okay. So I won't go with that the previous concepts like doing that data visualization and all the things, but it has actually required a few things as a very important. So that things one day I will discuss. Other than that, I won't discuss much about that topics. Okay. So basically, we want to understand what is logistic regression. So this logistic regression it is comes under the supervised learning. All this. Okay. So it is basically it is created to build the model. That model will be work based on the probability of certain class or certain event. Okay. So that is the very important. Okay. So it can be used to the model that model probability of certain class based or event based. Okay. So it is particularly used for the data is linearly separable. Okay. So which means it is focusing more on the outcomes in the binary data. Okay. So it is more on working on the binary data. Okay, I hope that I will give you. So it will be given the first point. It works based on the so model works based on the certain class or even. Okay. So second thing, so it will used for it is used for the linear data. It is used for linear data, which means labeled data. Okay. Third thing, and it will be used for the it will be like decided based on that outcomes, which mean output. So it's based on the output variable we are deciding if the output variable should be in a binary format. So binary mean like yes or no based. Okay, so these are the three conditions should we need to know about the logistic regression. Okay, so if you're talking about logistic regression, mean that model will be work based on the event or like classes. Okay, so that same model will be used for the linear data. Then only you can use the regression concepts. The output will be like output variable will be having in the binary format. Then only you can decide the algorithm. Otherwise, you can't decide. So, for example, you had it in the next you like in the last problem. So you have the data here, right? So there is the some linear data only. In the linear data, you had it in the last column. So this will be output variable. So that's why we are just taking this one, right? So in the output variable, you can see there is a continuous data only. So in this case, you cannot take the classification problem. Particularly, you can't take the logistic regression. So we cannot take it that one. So that is the reason we need to focus more on the output variable. If that output variable should be in the binary form, you can decide that things to go with the logistic regression. Okay, fine. In logistic regression also there is some extension. There is a multinomial logistic regression and order logistic regression. I hope that I will give you some idea, but we are not going to talk about all the things. Okay, so there is the one important thing. So one is called multinomial. So these are the types of logistic regression. So we can say types of logistic regression. Logistic. Okay, so there is same way simple logistic regression. So this will be used for the like a single independent variables. Okay, whenever we had it in the single independent variable we have. So if you want to predict something, we can use it. Suppose in the second one, that is called multiple linear logistic regression. So that is actually comes under the so multiple independent variable will comes to predict the one output variable. Okay, so this will be comes multiple independent variable. Okay, so independent variable multiple independent variable will comes to predict the one independent variable. Okay, so but in this case only we will have one independent. Okay, we have only single or one independent variable variable we will use it. Okay, so that will be a output as well as output as well as. Okay, so this is what the types of logistic regression. I hope you got idea. So next thing, so there is this some extension, which means there will be used on some problem based we will use. So there is a two things we can call it. One is the nominal multinomial logistic regression. Okay, so this is particularly used for like for example, you had a food, so you want to find out the food texture or you want to find out the soil textures. So like if you want to find out something on that food or soil textures, which means crunchy, mushy, crispy, I'm talking about food. Okay, if you want to tell that kind of things, you can use the multinomial. This is basically output variable should be discrete method. Okay, so discrete based. Okay, it is actually in the three or more classes we need to go. So in logistic also will supporting the multi classes, not only for binary. If you are going with the multi classes, you have to mention the multinomial logistic regression. So you want to tell that the food, you had a food, you want to tell about that opinion. For example, the food is very crunchy or mushy or crispy, like you want to tell. So there is more than three category, more than three classes you have in the data. So in the output data, you can use multinomial logistic regression. Okay, and that is another technique, ordered logistic regression. So that technique also, it is this kind of example customer ratings. Okay, so for example, customers are giving some rating for the products that are like, they are giving extremely dislike neutral, and it is like and extremely like. So there is some category, good or bad, like even that income level, low income, middle income, high income. So these are the things will comes under the ordinal logistic regressions. Okay, so this is also same thing. Variable should be in the discrete. That should be having more than 3 variable within the ordering levels. Okay, it is based on the order level, order based. Okay, so this will be not order based. So when I talking about multinomial, it is finding some kind of tasty, finding some colors of things. For example, you are looking the people, they are using some different colors on the hair, right? So like they have a green, brown, like they have a different colors. So we just finding that things. But in the order logistic regression, so that is order based, which means that is low level, middle level, high level, like that is the order level. So there is the even good, bad, bad, good, very good, like there is the order based, right? So if the data is there, if the data classes will be looks like that, we can goes with the ordered logistic regressions. Okay, so these are the things we have to know when we people comes to work with the logistic regression. But we cannot implement all the things, we just knowing about what it is and what are the things we can implement, that's all. Okay, so let's start to implement that things. So this is also the lines of forming, everything looks like a linear regression, but it is not exactly logistic linear regressions. Okay, anyway, let's start to implement that things. I'll have to introduce another one important thing. So basically this logistic regression, sorry, basically this logistic regression. Okay, so that is the very important one thing. Okay, uh, this logistic regression had it output with the 0 to 1. Okay, so for example, so you are predicting something means, for example, you are using simple linear regression, sorry, simple logistic or multiple logistic regression. So that output will comes between 0 to 1. Okay, so if you are using multinomial and order logistic, that will be different. Okay, but in this two categories, particularly for this logistic regression, the output will comes under the multinomial and multi logistic and the simple logistic. The output will comes under the two categories, 0 to 1 only. So for this calculation, we have a sigmoid functions. Okay, so for this calculation, we had a sigmoid function. Using the sigmoid function, so we will calculate that value, all entire value, that all entire output will comes under the 0 to 1 range. Okay, so let's see that. I'll just execute it. So like you can get that output like this. Okay, fine. So now, so we coming to go with the source code, which means we will start to implement all the things. Let's see that. Okay, I'll go with that directly programming. So I just importing some data sets. I had it this data sets already. I hope go data set, right? I'll just go to download data import. I just start to implement the algorithm. So I go with the import pandas as pd fish equal to pd dot read csv, and inside you need to mention that file path name. I have a file in C drive, which means users, and my name of download. I will check what is the file name, data set. Yes, I have this. Okay, I took the first file. Okay, I'll show you that file, then we will understand. So I taken that one file set. Okay, so if you want to do the experiment, you can download the data sets. If you need, I can share with you, and even that I'll share with you. Like your, like everyone need to do. Okay, I share the data sets. Okay. I shared the data sets, you can load it. Okay, I'll execute this one. So there is no issues. I want to see my data. Okay, you can use which dot head to be added data. So that is, I just taken all the data into the numerical form. But here you can just consider the data. There is a weight, where there is a length, there is the length 2, 3, and height width. Okay, but these are the numerical data. These are the numerical data. I initially mentioned what I mentioned. So these will be comes under the categorical based. Particularly, this will comes under the yes or no based. Okay, so the output will be in binary based, which means that data will be having categorical based. Okay, so we have to find out this will be output. So we want to find out that things like, so what would be then in this field. Okay, so you can find out. So before we have to check the things uniqueness. Okay, so like we have to check what are the categories are there. Okay, so I want to check the categories. Okay, 1 minute, I'll just check it. Fish start, and I'll just make it some particular value dot, and I take this variable, then I'll mention uniqueness. Okay, so you can see that there is the types of data we have. It is actually categorical data. So it will be work in the linear regression or logistic regression will work in the binary data. At the same time, I set in the what is it, multinomial also. Like if the data is output, there is more than 3 categories, so you can apply this. Okay, so like you can understand, so this is data will be some categorical based. You can apply other data also for the binary based, don't worry, because that binary based data is very common data. So you can also see the most of the examples in the internet. So that is the reason I'm not taking the data. So this will be very unique and it will be applicable for all other algorithms as well. As that is the reason I used it. Okay, so now I simply made it that one. So you can see in my output data I added some categories. Okay, so according to that I will going to work on here. Okay, so now I'm just defining what is my input. I'm selecting my features. Okay, if one is the X, so I'm just telling, like apart from this row, apart from this column, I need to select the other column. Yesterday we were discussed a lot. Some people may be feeling boring as well as. Can you tell the code if I want to select this all this column? I'm just waiting 5 minutes, not a problem. I want to select the input. These all the column. What is the code? I expect the answer from your side. So can anyone tell me the code for making the X as an input, weight, length, and length 2, length 3, and height and width? You have to use Python pandas library. Not in the previous case, we selected the variable, right? We should not do like that. So we have to like do the pandas library. I'm expecting some answer from your side. Yeah, please, sir. Yes, Praveen, sir.
Yeah. Sir, for selecting the X input, we have to write the name of our data, that is a fish. Within the bracket, we have to
Sir,
select the
if you
column
don't mind,
names.
sir, you just text it that one, sir. That one, sir. The people also will get understand, sir. Make it text in the chat, sir. It will be nice for us, sir. Thank you, sir. Thanks for the response. I'm expecting everyone. So how we can make it that one? Because yesterday we spent nearly 3 hours on this topic. That is very important. I hope that everyone knows all the things. So the thing is, we just need to do some practice, right? So that is the reason I'm asking everyone. So please text me that what out like what is the code we need to form for the feature selections. I want to select my features. I told you that what are my features. I want to select it. So I want to select this weight and length 1, 2, 3, and height and weight. Height and width, sorry. So I need to select this columns. How I can write the codes. I expect some answer from your side, please. I'm not able to get any answer. So please, I'm requesting you all to send the answer. Okay, I hope. So let's see that it is very simple to do because so that is the reason we need to give more importance. So like while you making the fundamentals, we need to give more importance because so this is the thing is very important things to take the data. Okay, so I simply use I location, fish dot I location. Okay, and then I told you that things like you have to make it the row part. So this is the entirely row parts I just given, and after I mentioned that which column I want to take. So actually, so this is the zeroth column. So this is the first column. So this is the second. Yes, sir. Great, sir. Great. So, like, I'm agreed that's it, but we should not we want to use the pandas library anyway. So that is also a thing. It is a right one. So, okay, fine, sir. Great, sir. Okay. So here I just simply using like which column from I want to take it. I want to take it from the first column. So this is the zeroth column. This is the first column, second column, third column, fourth column, fifth column, sixth column. So, okay. So according to that, I need to start. If I want to start the first column itself. So that is the reason I just mentioned one and colon simple. Okay. So then I executed this one. Okay. I hope that I faced the problem. And sorry, I given the space. Okay, fine. So now you can see that what are the things will be in the X. So that data has been I separately taken. So all the data I have taken. Okay. So next I want to take Y. So I want to take it Y. So I simply do Y equal Y. It is always in the small letter. Okay. So here also I'll run it. Okay. Y equals. So we want to take it the data this one, right? Here also I can use the I location. So same thing, fish dot I location. So what I need to do? I need to take this particular column. Okay. So like for the reason I can mention that zero, but it is actually it is not meaning. So in this case only you can give the name. So I given the name. That's all. I given the name. So fine. I executed that one. Okay, I'm facing issues. Let's see what issues I face. Okay, you can see the message here, what error I'm just facing. Okay, so according to that, you can change that things. So if you, yeah, yes, what error I face it? Like we have discussed a lot about this. That is the reason I'm asking you. So because, here I'm using labeled data. If I want to use the labeled data, I should not use the indexion location. I need to use only location. Okay. So in this case, I can use location and you can execute that one. Okay, fine. So now I can execute that data. So that is the input feature. So output features. Okay, that's all. Next thing I want to create or I want to do the scaling techniques. Okay, so I want to scale the inputs. Scaling means all the data wants to transfer into some format. So from that values to it will be transferred the data because each model will be getting different kind of inputs. So that is the reason we need to convert the data. So what I'm doing, I'm just doing that scalar the data. So from scale learn, it is also comes under the pre-processing. Pre-processing. Okay, so it comes under the pre-processing and it will be import and min max scalar, and after that I'm just creating scalar min max. I just initiated that one. After that I create the scalar for the fit x data. So and then I transfer the x scaled data, x scale scalar dot transform x. Okay, that's all. I just executed. So now you can see the X scaled data. So you see, so that in previous case we had it, the data looks like this. Okay, you see that X data, then you will understand what happened in that. So this is for the data. So each data will be converted into some transformation format for understanding the models. Okay, so model can be easily understand the data. Okay, so that is the reason I just converted these things. Okay, so next thing I'll just going to work with the another concept. Okay, so in this concept we are going to do encoding. Why wants to do the encoding? What is the encoding? So basically the data in output variable. So we have it in the output variable, some categorical based we have. So in the categorical based mean it is difficult to do that analysis in the model. So basically this linear machine learning models won't read the text data. So what we need to do? So we have to convert the data into numerical form. So for that I'm just using the encoding technique. Okay, fine. So now I simply do that large start to do the encoding. So I have doing label encoding, label encoding. Okay, so for the output variable, because that variable only having the numerical data. Okay, so I'll just started from sklearn dot pre-processing input label encoding. Oh, sorry, label encoding, label encoding. Okay, so that is called label encoder. Okay, I initiated, then I'll just go with that y and the label encoder dot fit transformations and y. So this will be doing the label encoding. So now you can see the y. So all this y will be become into some numerical values. That's all. This is what actually called label encoding. In the previous case, you can see it in the y. So it will be looks in the only these categories. Okay. So now it will be replaced for the so it is replaced the some numerical values. Okay. So now we will comes to split the data. So according to the data, the process step up, the process will getting different always. Okay. So I'll just go with that from sklearn dot model selection. And after that, you can import the package train split. Okay. Using that, you can make it. So you want to create X training, like X test, X train, X test. I'll show you that now. So how to use that X train and test. Okay. Y train, Y test equals. So you will go with that function train split, and then you will create that one. So what you will do? So first thing you will create the thing. Here we will write that thing. What is the input? What is the output? Okay. So here it is we have X scaled data, right? So that data is the input and output will be Y and another thing. So you have to mention what is the test size. You have to mention test size and that will be always 0.20. And after that, if you need to mention the random of data, random of selection of the data, you can give random size of data, random state. I given some value 42, 92, like whichever way you want to give, you can give. So that's all. I just executed this one. There is no issue with the issues with the splitting the data. So that is the reason I just go with the next thing. Okay. So so next case, what we need to do, so we have to go with the another one. Okay. So in the another one, so let's start to go with the after the splitting the data. So we'll start to build the model. Okay. So we will build the um, logistic regression model. Okay. Fine. So one is the like I'll just go with that. Okay. So first thing we have to import the package sklearn dot linear model and import. Okay. So you have to mention that logistic regression here. So I just mentioned the logistic regression. I import the package and I want to create the model. So I just doing the classification. So I just mentioned the classification model. Okay. So then I'll just return that logistic regression. Okay. So this is the model initiation. I just created a model. Now the model wants to learn it. CF dot model, sorry, underscore model dot fit function. So that now that is going to learn from the training data sets. Okay, so I have a training data x training, that is the input as a training and output as a input. Okay, so output also I'm just going to train it. Okay, so that is the reason x training, y training I've just given. So now I executed the logistic regression was learned from the data. The logistic regression model is ready to access with the test data. Okay, so now after that, so we completing, after that we need to predict the output, how we can predict it? Same thing, y prediction are, so we will use in the last case y hat, so that y hat will be considered the prediction. Okay, so that will be has cl like clf and model dot predict, and you can give x test data. So you had an input as a x test data, so using that x test data you are predicted some values. So these are the predicted values. Okay, you can see that. So these are the predicted values for the your given given input data. Okay, fine. According to that, what we are doing, so we are just going to analyze the another thing, which means we are just computing accuracy or finding the accuracy. We just computing accuracy. Okay, how we can computing? So 1 minute, sorry, 1 minute please. Okay, so sorry, so let's start to computing the accuracy. So when you computing the accuracy, so we can start from sklearn dot metrics. Using metrics only you can make it import accuracy. Okay, so I want to take it some accuracy score, that's the reason I just import from the metrics, and for that I just making accuracy equal accuracy score. So by that, I'm just finding that. If you want to find out the accuracy score, in the previous case also given, so we will given the y test data, comma, and then what actually we predicted. Okay. So according to that only, we can just find out the accuracy score. Now you can print the accuracy. So like print accuracy, print. So I need it in the accuracy. I need the model accuracy in some format of this way. Okay. 1, 2, F percentage. Okay, so I just need to in floating point, so that is the reason I just given format. In the format you are mentioning accuracy, so accuracy will be in the 0.9878, like we will get it right. So what I do, I simply multiplication by 100, which will be make it as the accuracy in the sum this format. Okay, so it is now 81 percentage point 25 percentage. Okay, so the model it is working, so 81 percentage accurately. Okay, so same thing, you have another techniques for evaluate the classifications. So in the same cases, logistic regression, we discussed about the evaluate model using MS mean squared error and mean absolute error, right? So in here also we have a technique that is called actually confusion matrix. I'll tell you that what are the things will come. Confusion matrix, and we had it, another one is called ROC and AUC curve. So like there are so many techniques. So these are the two techniques we will use majorly. So these are the metric confusion matrix will be we will use maximum of the problem. Okay, so now I'm just going to use the confusion matrix to evaluate my model. Okay, so like first thing I'll just go with the from sklearn dot metrics import confusion matrix CF confusion matrix y test data and y predicted data. Okay, so according to that we will format. So then we can make it in the graph as well as plt dot figure, and you can make SNS dot heat map. In the heat map you can mention the data annotation equal to, and then you can make it plt dot x label prediction plt dot y label target. Okay, so according to that, so we can just go with the plt dot title confusion matrix. Okay, see that PLT is not defined. So what we need to do for the PLT, we have to import the package. Okay. Okay, you need to import another package. Import Cbond. Okay. That's all. So this is what the confusion matrix. You can see it. So like, so you know that whatever we had it in the prediction. So these are the target variables. So according to that, we had our predictions. You can see that how it is impacting on the confusion matrix. So even that you can see that how many database supported and so for this particular purpose, like how many data it is supported for this, how many data supported, like you can see. So according to that only, we are just telling so this accuracy. Okay. So even that if you want to take the confusion report, confusion matrix report as well as you can make it. Okay, so there is no absence to do. Okay, so you can also make it the confusion matrix report also. Okay, so no worries. In next case, I will show you. Okay, so this is the way you have to implement the logistic regression. So now, so we will implement other algorithms. Okay, so we had it other algorithm. So there is the other algorithm, naive Bayes algorithm, KNN algorithm. Like we have other algorithms. Okay, so according to that, we will implement all this algorithm one by one. Okay, so if you're ready to do this program, I will share with you. You can also do this. Okay, I'll share this code and I will share it. So I will send you that same two files with you. You can use it. So I shared the two files. You can also execute in your system. Okay. So that's all. Let's start the other remaining algorithms. Okay. So let's start about that algorithms. Okay. So first thing we will talk about the naive Bayes now. So I'll go with the same data. So because I cannot take it the each algorithm different data sets. I'll go with the same data sets. Okay. So basically we need to understand about the naive Bayes. Okay. So 1 minute. Okay. So in the naive Bayes algorithm, basically it is actually rule-based or Bayes rule-based algorithm actually. So it is actually having conditional probability for finding the naive Bayes accuracy. Okay. So basically like rule-based means, for example, so you have a coin. So you have one coin. So if you are toss the coin, so what are the probability to finding the what are the probability for head? What are the probability for the tail? Like those kind of predictions will comes into the naive Bayes algorithm. Very simple. You have a one coin, so you are making toss. So in that coin, it is what are the chance to come the head, what are the chance to come the tail. So this is the probability can be finding or predicting using naive Bayes algorithms. Okay, that's all. Apart from this algorithm, so it is playing the major role in the NLP programming. So particularly for in Gmail classification is there, right? So in the Gmail classification, it is playing the major role for clustering, classifying the emails. Okay. So let's see that actually how it is will work. So what is the probability of the formulas? So this is the formula which will comes for the naive Bayes algorithm. It is entirely based on the probability of the events for the A and B, and even that it will be for the so it is entirely probability based concepts. Okay, so that is the that is the naive bias, which will be provide the formula for for probability of the y variable and based on the inputs. Okay, that is very important, and it is having to solve in this naive bias algorithm mostly to solve the real time problems. Okay, and here we can focus another one important thing. I hope that this maybe have seen it. So anyway, I'll give a simple example. So from that we will try to understand. So there is the there is the some table. In the table you have the animal, size of animal, and body color, and can we bet them. Okay, so like we want to decide. Like for example, so it is basically based on your interest, based on your hobbies, or based on your interest only you can decide. For example, you take a talk, so it will be size is medium, it will be color will be black or white or something. Okay, so then you can decide what you may like it or may not like it. Okay, so that decision will be based on the naive bias will be good. Okay, so that is the thing will be happen in the naive bias algorithm. Okay, so let's look at that another thing. So for that, how we can decide? For example, there is the data. So according to that, how you can decide that things. Let's see that how you can decide. So from that table, you just had it animal and size of animal and body color. You just divide the data into three parts. Okay. So animal and size of animal and body of color. So according to that, you will buy or not buy. Like I'll just so just I decided yes or no. So that is will be bet. Okay. So for the bet, I just calculating the values. Yes or no based, I just making that one. So tag again, like for the tag. So what are the yes? How many yeses? How many no's? Like I'll just take it. Okay, so I just taken this data. According to the data, I just divided into two parts of the data. So in the same for the size of animal, same for the body color. So we had a target variable. According to the target variable, we just divide our data sets. Okay, so like you can see here also I divided for the size of animal, and I did for the body of color. Here I did for the animal color. And finally, I can tell that how many votes will come for this. Okay, for finding that one. Let's see that. So finally, I will get that answer. So how many like a chance to bet with us? Okay. So that's the playing with the yes and no. According to that, how many playing for sorry, B for yes, B for no. According to that, we will decide it how many percentage will be mostly it will be comes for the yes. Okay. So you can take it that category into this yes, and this will be comes under the no. So this will be calculated from this tables. Okay. So these are the tables can calculate by the these are the things can be calculated by the naive bias algorithm. So in the naive bias, there is a two types. One is the Kaizen. Mostly we will implement the Kaizen only. So Kaizen, naive bias. Okay. So second one is the Bernoulli naive bias. Okay. So that is the Bernoulli naive bias. I will show it in the real time. Okay. So that is the called Bernoulli. I'm not right about that. I will show you that. Okay, so there are two techniques in programming. I will exclude it. Okay, I will show it. Okay, fine. So let's start to implement that algorithm. Okay, so if you want to implement the algorithm, I had it already data sets. From the data sets only, I'm going to work it. So there is the x and y. So what I did in the place of implementing the model, here I started, right? Here I started that. So in the same way, you need to import the package for the same package. You have to import the things. So how we can import it? Okay. Yeah, 1 minute. Okay. So we can explain more detailedly. If I take one algorithm, so it will take long time to compute all the things. Okay. So naive bias, it is an interesting algorithm. It will take long time to complete actually. So I hope that I don't want to talk more about the theoretical. I'll just going to directly discuss about the content. Okay. So, okay, fine. So when you just I deleted this all. Okay, so because we will start from here only. Okay, so when you coming to start the code, so usually like we have to start from that codes start from scikit-learn from scikit-learn, scikit-learn, sklearn, okay, dot. So you can mention model selection, okay. So we'll go with the model selection. Okay, so like if you not go with the model selection, you can specify the that particular package. I want to that one naive bias. Okay, I'll just make it naive bias, and then you can import. So here it is. There are so many algorithms in naive bias under. So for example, you can see that Bernoulli, and that is also naive bias algorithm. Categorical naive bias algorithm is there, and complement naive bias algorithm is there, and you can see that Kaizen naive bias algorithm is there, and you can see that yeah, and multinomial naive Bayes algorithm is there, and base discrete naive Bayes algorithm is there. Like there is very important algorithm we had discussed. Okay, so particularly we will use the Heisen naive Bayes algorithms. Okay, fine. So after that, what we will do? So after completing this, I'll execute it. There is no issues. After that, what is the thing we will do it? We will create the model. Okay, so I'll just give an naive Bayes model. I'll give a naive Bayes model. Okay, so in this model I just created that one Kaizen. So I initiate that model, done it. So after that, usually we will train the data. So NB model, naive Bayes model, so same keyword only will comes under the all the cases. Okay, fit function. After that you can give X training and Y training. Okay, I executed. So now the Kaizen also executed, there is no issues. Okay, so now we will let's start to get the explanation of this all this. Okay, so here we want to get the predictions. Okay, so here we are going to create the naive Bayes classifier, okay, using that nb underscore model. Okay, so let's do that. I just go with the from dot matrix is in dot matrix input, same thing, accuracy we had it already. Okay, so we had it, now going to find out the accuracy score. Okay, so then we will go with the other things. Okay, so yes, I hope here it is all the codes. You can follow the same concept, same codes you can find out. Okay, so like I'll just do that prediction score before. I just want to find out the accuracy, predict the accuracy. So then I'll given the y prediction, y is the prediction equals, in that you need to tell that prediction nb model dot prediction, right? So in that prediction you need to mention, so what does that data, so you have to mention that two data. Okay, which is the training data, x test data, sorry, x test data, you have to mention the x test data. So now the prediction where happened, you can see the prediction now. So these are the prediction we had it. So this is actually Heisen naive Bayes algorithm prediction. Same thing you can see it in the logistic regression prediction as well as. So let's took this as well as, I just copy it for making comparison. Okay, I'll just make it under new cell. See that? So like in this prediction, in a first case, it is predicting for 4, but this algorithm predicting for the 2, and this algorithm prediction 5, this algorithm also predicted 5, and here it is predicted 2, here also predicted 2, and here it is predicted 2, and here it is predicted 4. Like there is so many complexities, right? Let's see that. Like let's finally we will decide which algorithm it is good. Okay. So what I do next? Okay, so I'll just go to after predicting that. So let's go to work on the, I'll start to work on the accuracy score. So you can take it the same score. So like you can take it the same thing, because you know you are using the different model only. So you have to mention the model clearly for that. Okay, so I'm just using that whatever I predicted in this variable data is there. It's just taken, and then whatever void test data it is taken. So now we executed that one. So you can find out the accuracy now. So in the previous case, we had an accuracy. What? How many percentage we got the accuracy? 81 percentage. But in this algorithm, it is showing only 65 percentage. Okay, so that's all. Okay, fine. According to the next step, what we are going to do? So let's start to implement the metrics. Okay, so like we wants to understand that. So how it is actually supporting to do this. Okay, so you can see that. So these are the supporting item of data for this predictions. Okay, fine. Here in the 7 data were recommended, but in the previous cases 9 data were recommended for this 2. So that is the reason in the output you can see it more of the data would be 2. Okay, so these are the logistic regression outputs. Okay, you can see more in the 2. So because more of the data are supported for the two. Okay, fine. We have less data. That is the reason we cannot get more accuracy. So now we completed the naive Bayes algorithm. So let's start to work with the another algorithm. Okay, so after naive Bayes, we will go with the KNN algorithm. Okay, so let's try to understand what is KNN algorithm. So same data we are going to work. Okay, so we just simply trying to understand what is KNN, then we will go with that. So KNN means like basically this algorithm comes under the clustering as well as classification as well as. So basically we had a two group of data. Just assume in the KNN algorithm. Okay, in KNN algorithm, just assume. So 1 minute, 1 minute, I will call you back. So sorry.
Ramar, you're on mute.
Yeah, I'm really sorry. I'm really sorry. So I just uh, had a call from my team. So sorry, Mayank, I just came to back. Okay. So I just now only started. Okay. So now we are going to talk about KNN algorithm. So this KNN algorithm, simply what it will be looks like, so there is the like we had a binary like classification data. So in the classification as well as there is the three groups or four groups or two groups of data, right? So in our data, we had it in the nearly six group, I think so. Okay. So in that six groups, as you can see that. So here it is nearly seven group of data is there, right? So in the seven group of data, we have divided, right? So in that, in middle of the place, we have a new data, or we are receiving as a new data means we need to find out that the new data is which blank group, which belongs to, or that new data will be like comes to which group, like we need to find out. For that, we will use the KNN algorithm. So this KNN algorithm, it is more effective algorithm, which will be finding based on that entirely features, right? For example, this new data came. Okay, so it will be finding. So like what kind of feature it is having? It is similar to A or similar to B. So like it will be finding the KNN algorithm. So based on that, it will be add the data into some categories. Okay, fine. So this is what that KNN algorithm predictions. Let's see that how it is actually working. This all the things. So basically, this prediction it is like this kind of prediction it is based on the distance of the data. It will decide it. Okay, so for particular this data, it will be close to here, right? So according to that, it will be saying that it is a category of B, like it will be predicted. Okay, so this is what using. This is the thing will be happen in the KNN algorithm. Okay, fine. So how we can implement this algorithm? Another important thing. Basically, this algorithm many places that people are using. So here it is some disadvantages and advantages I want to discuss because other algorithm that much not important, because not important means basically the most of the faculties, most of the research paper you can see that. So the people will use KNN algorithm even that for like cancer prediction, even diabetes predictions, like those kind of places I can see it. So mostly this KNN algorithm they want in the real time problem, so they will use for the classification applications. Okay, but we can see it in the kind of research papers. You can see that advantages, it is very easy to implement. That is the very important thing. At the same time, understanding also very simple. And here it is, this particular algorithm will comes under the learning, lazy learning. It is simple concepts. It is not doing hard work. So what does the lazy learning mean? While coming to work with the KNN algorithm, the KNN algorithm, whatever input we had it will be work in layout based. Okay, but like hard learning means it is work very depthly about the data, but the KNN algorithm it is working very lazy. So it is actually advantage, and at the same time that is the same thing will goes as the disadvantages some cases. Okay, so KN does not learn during the trainings passes. Okay, so KNN algorithm does not learning. So when we do the training passes, it won't learn. So when we had a new data points, that time it is added into the data model and it start to perform the algorithm. Okay, so this is the advantage and disadvantages. There are so many things. It fails with the variables have the different scales. Okay, and it is having the difficult to choose the k values, which mean that creating that clustering concept it will become. Okay, and there is the interpretations, right? So when comes to go with the ambiguous interpretation also very difficult, and it is having the outlier problem also we will face it. If you have that some outlier, that is also like show it in the normal output, and even that will be comes under the missing values also will be accepted and it will be do it. Okay, and it is not good in the large data sets. That is the problem. Okay, so that is the reason I won't recommend. So okay, let's go with the implementations. Okay, so when comes to do the implementation, same concepts we need to go and we need to implement. Okay, so basically when comes to implementations, yes, same algorithm, same format we need to follow. So we will use that scalar dot neighbors. There is a neighbors, right? You can use the neighbor package and you can import KNN algorithm. K neighbors. So we have a KNN algorithm. So we can see that package. 1 minute, I'll look at the package. So we don't want to remember all the things. We can just take it that all the things there. Okay. So we just go with that. Classify. So we need to go with the KNN algorithm. So we have to mention that for specifically we have to mention classify KN sorry KN mean K neighbor classifier is not came in the tab button. So I'll just make it type it. Yes, it is. Okay. So KNN also will support for the classifier and regressor, even that if you want to data transmission, you can do. So, but we are working with the classifier. That is the reason we need to go with the classifier. Okay, fine. It is executed. And other remaining things, same thing. You need to follow that. Like whatever things we did that other previous cases, we need to follow. Okay. So, like I just create the model. So KNN model classifier model. Okay, model equal, and usually you have to create that model application. Now the model is started. Now the model wants to learn the data. Okay, so for that I'm just given model dot fit function. So then you are giving x training, y training. Okay, you are giving y training. After that, you just make it that model start to learn. So model was learned. Now we just going to work with the prediction. Okay, so I just going to find out the prediction, y prediction. Actually y card simple. Okay, here I just make it KNN underscore model dot fit function, and you can make it the X test. So for the X test, sorry, and the Y, sorry, yes, I just given the prediction, right? So I just given the wrong, so I just predicted the value. You can see prediction values. So you can just execute the predictions. So these are the prediction values. The previous case, we just predicted for the, what is the algorithm? So this is the Guyson naive bias algorithm. Okay, I'll show you that naive bias algorithm. So this is the NP algorithm. Okay, we had a prediction. And similarly, we have logistic regression prediction as well as I'll show you that. Let's do the comparison. That's all. Okay. So yes, we had it here. Same row, same column we are doing, right? So that is the reason I'm just taking. So this will be comes under the KNN algorithm. Okay. So like let's see the prediction how actually it will be getting different for the KNN algorithm. Okay, so like you can compare laterally, we will do that comparison. Okay, fine. So next thing, so we started to another important. Okay, so we will do that another thing. So after predicting that one, so we need to evaluate the model. We need to check the model accuracy. So like you can start the same code for finding the accuracy. So you have to go with finding accuracy. So let's see that. I'll just go with that accuracy finding. Then you can make it the accuracy. So you will get the accuracy. Okay, so this algorithm nearly working 87% accurately. Okay, fine. And after that, you want to go with the model evaluation, which means you have to see that confusion matrix. You can go with that and you can make it the things. Okay, So we simply given that inside data only, like whatever we predicted, whatever we tested data. So we simply applying that data. So we will find out the predictions for the, sorry, confusion matrix for the this particular KNN algorithm. The KNN algorithm for making the prediction for the two, so category of two, it is supporting three items. In the same item, actually supporting for the target output, which means it is supporting 8 items. So in the same category, in the prediction, it is supporting for the three. It will be three items. It is supporting for the target as well as, okay. So according to that, like, you know, we can understand that how data is supporting for the prediction accuracy. So as per that, it will be given the 87%. Fine. So after that, we will implement the decision tree. So we know KNN algorithm. Now we are going to implement the decision tree. Okay. So if you want to know the decision tree, it's this. Okay. So let's see that decision tree implementation. So that is also very same way we need to develop. So we have to understand how it will be decision tree will be looks. Okay. So basically this decision tree, like for example, in our case we had it. Just assume now. So we had it 500 data. Okay. So what will we do? We will do it. So in the decision tree algorithm. So basically, so that it will be creating some models. Like, you know, so it will be creating M1, just assume M2, M3. So there is the three modules or four modules or five modules is there. Just assume. So each model will be receiving 100 data. Okay. It will be receiving 100 data. It will be receiving 100 data. So this is actually not model. It is a tree. That is also process actually. Okay. There will be tree in the decision tree. So that will be taking the 100 data. This will be also taking 100 data, and this also will be taking 100 data, and this also will be taking 100 data. Okay, we had 1,000 data, sorry, 500 data. So all five decision tree, it is taken 100 data, and each decision trees, I mean trees will be providing some mean value. Okay, it will be providing some mean value. It will be providing some mean value. Will be providing some mean value. So finally, so we will find out the, from all mean, we will find out the sum of mean and the sum of mean value, and we will finding the average as well as, okay. Then we will find out the average as well as. So this average will be considered the accuracy of this decision tree. Okay, here you may have the doubt. So there is the training data sets, and the training data sets we had a 500 data. In all 500 will be separately, like, you know, first 100 will be goes like this, goes for decision tree 1, and for second 100 will be goes to decision tree 2, decision tree for the second 100. Not like that data will go. So data will be goes randomly 100 data. So randomly it will randomly select the 100 data. Okay, select the 100 data every trees. Okay, so this is will happen in the decision tree. So when you are making implementing the decision tree algorithm, so it will form the some amount of decision trees, and each trees will be receiving some certain data only. In that each certain data, it will analyze each accuracy, which means it will be receiving, it will be calculating some mean value. So based on the mean value, so it will be getting overall the decision trees. For example, you are working with the 10 lakhs data. Just assume you are working with the 10 lakhs data, means according to the 10 lakhs data, so based on the decision tree, it will create these sub trees. So based on the sub trees, it will be creating some mean value. From the mean value, we will find out some average values. Okay, so that average value will be considered the decision trees. Okay, so this concept, it is easy to implement, so we can implement that one. So how we can implement that thing? So we can go with the decision tree classifier. Okay, so if you want to import the package, you have to go with the make a classification. 1 minute, I'll just go with the import tree. Okay, so I'll just import from sklearn dot tree and import. So you want to import, you want to take the package is called decision tree classifier. Decision tree classifier. It will be support as well as further regression. I executed this one. It is executed. There is no issues with that. And after that, what you can do, you can start to implement the other remaining things. Okay, usual one. So like I'll just want to create the model, decision tree model. Okay, I'll have the decision tree classifier. I executed the model. In the inside the model, I just taking to I mean test the data. Yeah, fit, and you can give X training, Y training. Okay, I executed, the model was ready. So now you can predict the data, you can test the data, Y prediction. Okay, so then you can give them variable like TC model dot prediction. You can give for the X test data. So now you can run that X test data. You can see that what prediction we had it. So these are the prediction which added by the this decision tree algorithms. Okay, and similarly you can make it the you can make it the accuracy. Okay, so for the accuracy, you know that what we need to do. We have to import the package accuracy, and then from the accuracy you can make it. So you don't want to type it that thing. So you even that you can make it like a TZ model dot accuracy. Okay, it's not key. Anyway, we need to import. So I just done that. So then we will find out the accuracy. Okay, then we will find out the accuracy. So let's see that this is what the accuracy. So this decision tree is giving the 75% accuracy. More real time, more industry problem will be solved by the decision trees and random forest only. Okay, so that much important algorithm. So if you want to put in the random forest, you have to compulsory know about the decision tree. So if you know well in the decision tree, then only you can work on the random forest. Okay, so this is the model accuracy. If you want to evaluate by the confusion matrix, you can make it for that also. In here that you can see that how the data is recommended for the true for that particular values. Okay, for this prediction of 2 is impacting 6 data, and you can see that other things as well as. Okay, so this is the way you can see that evaluation of class pair problems. Okay, I hope that we done that all important algorithms. Okay, so if you want to implement the random forest, you can also import that, make it that. So that random forest is little advanced algorithm. It is similar to decision tree. Okay, so the random forest algorithm will help to find out the shortest path, or it will help to do the optimization. Okay, so let's see that how we can do that random forest. Okay, I'll just taking the package random. So basically that will be looks like this. I just given small image. So that's what in the decision tree also will do, but it will be little different when compared with that. Okay, so I'll just show random forest. Okay, so basically it will be looks like this. Okay, so this will be looks like. So this is what actually random forest. So we will have so many decision trees inside the random forest, and then we will finally get the average of the output. Okay, so this is the random forest. Okay, inside that random forest, we will have the many decision trees. Okay, so according to that, we let's start to develop that algorithm. So in here, we will use the function is called import sklearn. Uh, ensample technique actually. So why we are calling as a ensample technique? Because so this particular model having inside so many model 1, model 2. So that is the reason we have to go with the ensample learning. Actually, whenever we talks about the machine learning random forest, it will be comes under the ensemble learning concepts. Okay, let's see that if I want to that from learn dot ensemble import, you can make it random forest. Okay, so that is the random forest classifier. You can take it. That's all. I'm just executing this one, and after that I can go with the other things. Like I want to create the model, RF model world, and you can make it random forest, and I executed that one. And after that you can give the RF model dot fit function, and inside you can give some values. Particularly you have to mention that X train, Y train, executed. So model it is executed, that is learned as well as okay. So next thing we need to predict it. So why prediction? We have to test the test data. Okay, y sorry, RF model dot prediction by X test data. Okay, so now you can see what is the prediction of y test data. Basically, in this case, we had a very less number of values. That is the reason I'm showing that all the data. But in the huge amount of data, like no use to see all the data. So we need to do only finding accuracy, and we need to do the data visualizations. Okay. So after that, we will find out the accuracy. So when you are finding the random forest accuracy, it will give around, I hope, will be given 78%. Okay, so these are the algorithms will comes under the classifications. So only thing remaining support vector mission. So you can also same thing do that in the same way. Okay, so if you want to go with, I hope I will try that support vector mission as well as I will just. Okay, so I will just go with that support vector machines. Okay, so in the SVM also, like it will be finding that some like so this is the simple example for understanding the support vector machine. Okay. So basically we have two groups of the data. So that is the, we will form different kinds of line inside the data, which mean there will be center line, there will be neighbor line. So like we will follow that, like we will make that lines. Okay. So according to that, we will find out which is the very closest to that particular data sets. Okay. For example, we will form that very like support vector machines will be formed. Okay. So these are the lines will be correlated with the data which is very, very near to the data. So accordingly, we will form the line. So based on that, we will decide the data. So how it is actually there. Like for example, data is looks in the non-linear, linear. Like in this case, it is very difficult to divide the or classify the data. For example, you will find out the last one. The data will be looks like a curve shape, but we need to find out the differentiation of the data. So for that, we will use the random or sorry support vector machines. Okay. So in this place, we will use it more on this support vector machines in real-time applications, even that the parallel computing, like in the high computing systems, they are using support vector machines. Okay, so now we will start to implement that concept. Okay, if you want to implement, you have to import the package sklearn dot model, like so we have to use the SV. So that is the reason we have to from learn that SVM. Yes, SVM, and then you can import the which thing you need. So now we need to use the classifier, right? So we have to mention that algorithm SVC. So yes, 1 minute. Yes, ma'am. Yeah, sorry. So we just import the package SVC. Okay. Support which vector classifier actually I imported. I'll just execute that one. So accordingly, I can execute that other remaining parts like it is very same. We do not worry about anything. Like we can start it again. So this is the SVC model. Like you can see that SVC classifier. I'll execute it. And after that, you can like train that SVC model. Okay. Dot fit function. You can give X training, Y training. So now SVC also executed. Then what you need to do, so you have to predict it. Okay. So why predict it? SVC model that predict X test data. So then that prediction is came. So you can also look at that one SVC predicted. Okay. So you can see that. the prediction outputs for the all our data for the x-test data set. Okay, then what you need to do, you have to find out the accuracy. You can see the model accuracy. So this also nearly comes. Okay, yes, it is giving more than accuracy 87%. Okay, so it is there is this 87%, it is accurate. Okay, now you take all the algorithm, you take all that algorithm. Okay, so like you had it so many algorithms accuracy. Now for this comes for the what is it, support vector machine will be considered 87%, and we had it go with the random forest 78%, and you can go with the another algorithm that is called decision tree. This is providing 75% accuracy, and even that will be KNN is providing 87% accuracy. And then you can look at the KNN, what is that? This one still comes under the algorithm. Yeah. Naive Bayes algorithm, it is providing 65% accuracy, and logistic regression, it is providing 81% accuracy. Finally, so you can conclude about this all algorithm. So almost which are the algorithm that is providing more than 87% or 80% accuracy. The maximum that 87% accuracy can given by the KNN algorithm, and apart from that, you can see that support vector machine. Okay, so there is the two algorithm it is provided. So basically, we need to compare about the two algorithm. Support vector machine is the very hard work algorithm, which means support vector machine will be working very hardly. So that is the reason we can take it. So because KNN algorithm is the very lazy learning. So this kind of a learning algorithm, we cannot take it as the serious cases. Okay, so when we compare with this algorithm, so in this case, I just recommend only this particular support vector machine. In the second cases, in next level of hard work learning system will comes under the random forest algorithm. Okay, so in that case, I can give the 78% accuracy. I can take random forest or support vector machine only as a best algorithm for this particular data. Okay, fine. I hope that I explained all the algorithm, and practically I will execute that all the algorithm. I will share once again this files with you. If you have any queries, please ask me. I can help you. Thank you all. If you have any queries, please let me ask. I can help you about that. So no queries. Can I consider as a no queries? So you can ask whichever questions you want to ask. Please ask. I can answer it. Yeah, I shared that file. You can utilize it. Okay. So thank you all. So we will meet at the 1:30. 1:30. So okay, after the lunch we will meet. Thank you all.